So we're going to do these reading examples from the Ant1. And I've opened this by, I'm doing the reading examples script here, but to set the working directory to this location, the analysis folder of my project, I click the cogwheel and I click set as working directory. And as long as the file sort of view is of that directory, it will run the command that you'd need to do that. So we're going to use the read.tsv function from the reader package to read in a single file. The data is located, again, up in the parent folder, ant1, and then down in one folder called data. So if I were to read one file, and I happened to know that it was a tab-separated file, I can use read.tsv to read that in. As I run that function, I'm assigning the result back into D1, but it's also printing out some messages for me. What these messages are saying is it's found 1, 2, 3, 4, 5, 6, 7 columns in the data, and it's made a guess at what is in those columns. So it's guessed that that first column called subnum has an integer, integer, integer. This column called Q has characters in it. This column called flank has characters. This column called RT is a double. And this column called error is an integer.
I got one saying that one of the, I have a warning, one person failure, row column, row 2,
Ah.
7. Row 2 expected 7 columns, actually 6 columns.
I think that's because the other day we'd actually opened up this file in our studio and started messing around with it.
I just didn't make 9.
So I think we took out this number. So if I take that out, let's see, do I get that same error message?
Mine also says reader says double, mine says character. Which could be
in RT, and I think that's because we had another example. Let's see, of like we put none or something there.
Look, my row 2 is missing anything though.
Is there, so there's a number there.
Yeah.
Maybe it doesn't have the last 0 at the end. Let's see.
Row 2 or actually row 3, but
No. This one is the code we just ran. It's the TSV. So, it gets the text file.
Oh, okay.
So you're looking at a different file.
Oh,
When you
okay.
look at .csv,
Okay.
that's a different file in there.
We deleted different ones here. I deleted this one.
So yeah, we fiddled with the files yesterday.
Oh, next one's missing. That's enough. Should I copy what that number is up there?
You don't need to, you could just put any number in there. So what I'm going to do is take my data file, and if I put, say, some other character here, save, and I'll run this reading in. It's read in the data okay, except that if I look at the data, it thinks that the RT column is now a character. And if I look at it, well, if I look at it, it's read in that character string none as a character string, and having hit that as a character string, it interprets all other sort of contents of that column as a character string. So we had that example from yesterday where we had some other software generating our data. It doesn't know that R is expecting the capital N, capital A as the missing data thing. Maybe it's generating a string NONE as its sort of signal for missing data. So so we would need to tell R about that. Read.tsv, I mean, it still works. We just need to tell read.tsv, use one of the arguments, na.string equals none. I have to look at read.ts or underscore tsv. Call names, call types. Oh, read underscore delim, which has all the same arguments as read underscore tsv. There's an na argument, an argument called na, that accepts a list of strings that should be considered as na values. So that's the name of it. Having run that, looking at sort of the output, it's correctly now identified RT as a number. If I try to see the first little bit, that first one that I had none in there before comes out as an NA. This one is NA because in the data set that we're reading in, it actually, when we were playing with it the other day, I had deleted that value. And just to demonstrate that when you have a truly missing value, in the sense that there's a tab and then nothing and then another tab, it treats the missing value as NA.
Can you, sorry, you might have just said this because I saw you wrote string. Can you write like NA equals 999?
Yep.
Okay.
Yeah, you can, if it were 999 that your software was spitting out, you just put 999 there.
Okay.
And if there were several strings that could mean the same thing, you can actually put them all together. And if what it encounters matches any of them, it will, sorry, the C is that combine function that we had from the beginning that takes each of these strings and combines them into a single sort of list. So there's a lot of like tweaking that you can do to these reading functions to accommodate the quirks of your own data files. So this is read.tsv. If you had a comma separated file, there's read.csv. Read.tsv and read.csv are both sort of functionally underneath the table calling read.delim. And if you want to sort of, there's actually a really nice in RStudio way to visually see what is happening in your data using this import dataset function. And even if your data isn't the CSV, but maybe a tab delimited file or some other weird delimiting, you can still use this from CSV option here, and it's going to bring up a nice little GUI. So,
that not everyone has that.
ah,
I don't have, what's in your file? I don't have.
ah, file import dataset. Oh,
Yep, nope.
okay. All right. Well, I'm special. No, actually, what's happened is I'm running what's called a preview version of RStudio. Let me. If you Google RStudio preview, it gives you the download links for a preview version that might have a couple bugs in it, probably not, but definitely has more features. So you guys should check out this preview version because it has this neat import wizard. So the way this works, brings up a little GUI and graphic user interface window, something that you can point and click and achieve things. So you can look for the file that you're interested in. So you can also just use the, I'm going to hit cancel, use the string that you were going to use in your call here. So I'm going to go back, open that little thing, and I'll just put that in. And having run that, it actually will give you a preview of what it would try to read from the data. And here are all the options that typically you'd use arguments for. So for example, right now it doesn't look like nice spreadsheet look. That's because right now it is assuming that it's comma separated values, but I know that it's tab separated values. And so it updates and it shows, hey, it found tab separated. Additionally, if I didn't have the first row being the header, I'd want this unchecked, in which case these would be considered entries. But those are headers, so I want to leave that checked. Can I set an NA in here? You can't tell it what's NA here. But what you can do is once you get everything worked out except for maybe that, because you're using a weird NA, you can just copy the code that it's producing here. And that's the code that, once you get it looking the way you want up here, the code that is down here represents what you'd want to run to achieve that import.
But we can only do this if we have that preview version.
Yes, yeah, so you'll want to download that. So that's, yeah, a really useful little tool to try to figure out when you've got, I mean, most of the time data sets are structured nicely such that you don't need to fiddle with that. But when you do need to fiddle, that gives you a nice way to preview what each of the options does and how it's going to affect the reading in of the data. Some people are working in labs where they just have one big spreadsheet that has all their participants, and that's like the first time the data hit a computer. So you might have people just entering the data into the spreadsheet. Other times you might have, say, a computer program collecting one file per person per session that the person's in being tested. Or maybe a questionnaire file comes in from your server per person, that sort of thing. In the case where you do have those many files, this is actually the example that this experiment, this ANT1 project, sort of exemplifies, is that each of these files is a different participant in an experiment. So I want to be able to read in all of these files. Now I could just copy this and say D2 is read subnum 2, etc. But that would start getting really annoying by third or fourth one, and I've got like 20 people here. So what I wanted to be able to do is get a list of all the files that are in this directory and just automatically tell R to just read in all the files from that list. So there's two steps there. First, getting the list of files. There's a function called list.files. It has several arguments that are useful. So path. By default, list.files will look in your current working directory, but our current working directory is the analysis folder. We want to tell it to go up one to the parent and then down into data. So that's what the ... slash means, go up one. ... is go up one, and then go down into a folder called data. Pattern will specify sort of only grab those files whose name matches the thing that's inside here. Now, it doesn't need to be a full match. Like it could be, if it finds this set of characters anywhere in the name, it will read it. I happen to know that in the list of files that are in that folder, all the ones that I want end with .txt. And there's no other files in that folder that also have .txt somewhere in it, but I don't want it. So .txt is a nice discriminating string to use to grab all those files. And this last name, full.names equals true, means that it's going to append the full sort of the path to this location. It won't just grab the file names, it'll grab the full path. So we'll see what that is in just a moment. I'll say print files. Yeah, all right. Well, let's actually comment that out first. So I'll comment that line. Full.names equals true. Make sure that it's got a hash mark at the beginning. I'm going to make my viewer a little bit bigger. So if I run this, and that's going to create that object, files to read. If I print what's inside files to read, it's a whole bunch of strings corresponding to the files that it found in that directory. What happens if I uncomment that line? So now it's going to run, and I rerun this. You'll see that it has that ... data bit at the beginning of all of them. That's important because later we're going to use these strings to read in data, and we need to ensure that it knows that this data file is in a folder called data in the parent of the current working directory.
Why does full names equal T though?
What's the T is short for true. R just happens to interpret that single capital T the same as if you put TRUE.
So it's like you're just keeping the direction of where to go to find each file?
Yep.
So in the middle of doing this, you want to change your directory, what would happen?
So if I changed my working directory, it would look for these files in the data file. It would look for a data folder inside the parent of whatever directory you've changed it to, and it would, which is why it's a good practice to either, when you're going to start working on a project, open a fresh RStudio session by double-clicking on that projects.r file, or make sure right at the beginning of your session to set the working directory properly. And I mean, all that's going to happen is if you haven't set it properly, it's just going to yield errors every time you try to do stuff. So, all right, so having created this list of files, we can now use that list of files to read in all those data sets. So the mapdf is a function that comes from that purr library, P-U-R-R-R. And that mapdf has two arguments, .x, which is just a list of things. It's expecting you to give it a list of things. And .f is a function to apply to each element in that list. So what we want mapdf to do is to take each element in the files to read list and use that value as the first argument to read.tsv. So notice the first argument to read.tsv is the file name. So mapdf will automatically go in, see that this has 20 items in it. It will grab the first item in files to read, which is, say, this file name. It will run read.tsv with this as its first argument. And then it will run read.tsv with this as its first argument. Then it will run read.tsv as this with the first argument. So it's going to collect, each time it's run, it's going to yield a new data frame. And at the end, map.df is going to combine them all together into a single data frame. So it's the same as having read in each file individually with read.tsv, but we can do it just in 3 lines instead of lots of lines.
So you said it'd be all in one data frame?
Yeah, so it combines them all together into one. So I think what's happened here is that first file that I messed around with, it wants it to be the same as the others. As long as they all have the same format, it'll read in properly. But this one, here, I'll just put an NA there. And we'll put it back to the way it was. So mapdf, it will actually spit out that same read.tsv, that same output that read.tsv had for every single file that it read in. So there's going to be 20 of these. They're all identical because the content of all those files have the same sort of format where it's integer, 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 character, character, double integer. Notably, you can actually put any reading function here. So if you decided read.csv is what you needed, you could put that there. If you decided read.delim is what you needed, you could put that there. And if there were other sort of arguments that you needed to put here, so if, I guess, above we decided that we wanted to accept all of these as sort of NA strings, I can actually take that same argument and just paste it in here. And mapdf knows that this is a named argument for the function we're giving it as .f. Did that not work? Oh, actually, it wants... So yeah, any arguments that if reading an individual file, we decided we needed to supply to whatever file reader function we're doing here, can be similarly applied or supplied when we're reading in lots of files using mapdf. Yeah. This last here, actually, how much time do we have? Oh, no, yeah. Well, sometimes maybe I've encountered sometimes that the only place where the subject number is actually in the file name, like the file doesn't contain the subject number info. If you need that file, if you need the file name to actually be inside or I guess associate with the data that's part of that file, there's an argument to mapdf called .id. And if you give it anything, it will use the thing you give it. You need to give it a string, and it will create a new column in the data set that will have that string, or have that column named whatever string you give it. And the numbers in that column, for some reason it says character, but it's always going to be a number in that column. So the number in that column corresponds to what element of files to read corresponds to that section of data. So it's a little...
Wait, so is it taking the whole file name and putting it in a variable called file num, or is it just
it's just getting like the index of what was like. So it grabs the first element from files to read. It uses that as the first argument to read.tsv, creating a data set. And then, knowing it took the first element of files to read, it creates a file num column and puts ones in that column. Then it grabs the second element of files to read, grabs the data, creates a file num column, and puts twos in there. For some reason, it then turns it back into a character, which doesn't make a lot of sense to me. So this code here.
Would it turns it to a character because it's like a nominal variable, it's grouping?
Well, it is literally just the index of, like, it can only be a number. There's no circumstances under which it's going to be anything other than the integers
But, like,
1
it's-
through.
But it's a grouping variable, not because it's just used to an input group, which file.
That is good thinking, and that may indeed be why. That in any subsequent analyses, it would be a shame if that column were used as a sort of truly continuous metric variable. If you wanted to grab the actual file name and have that as a column, I've got a couple lines that show how to do it. It's a little bit different from. I mean, I could have used mutate for this thing. So I convert the character column file num. I grab so what this $D means, D is the data set that it's coming from. $, means look inside that data set. And the thing on the right of the $, is the name of a column. So this says look at the D data set and the file num column inside the D data set. And convert it to a number. That's what as.numeric does. And assign that back into, again, a column called file num inside the data set called D. So we're just overwriting what's in that column. I could have created a new column, but I was being lazy. So that would create a new column if we look at that would overwrite what's in that column. And now it's treating this as a double. This one creates a new column called file name inside the dataset D, and in it puts the result of whatever's on the right-hand side of the equal sign. And this is a little bit not esoteric, but a little bit complicated insofar as this files to read is a list of 20 elements long, and I'm using these square brackets to say grab items from this list. So square brackets, if you use the square brackets and have a 1 inside the square brackets, that means grab the first item. 2 inside the square brackets means the second item. Instead of 1s and 2s, I'm passing it the contents of this file num column. So it's like a whole bunch of 1s and then a whole bunch of 2s and a whole bunch of 3s. So that, despite the fact that this is only 20 items long, it's going to want to spit out 5,760 elements. But R is smart enough to realize that it sort of auto-expands this to have the right size. So it'll grab all the first elements whenever this is 1, it'll grab the second element whenever this is 2, etc. So running this effectively means it retrieves the names for all of the associated with each row of data. So now we've got this thing, and of course, since it was read in sequentially, the first 288 rows are actually from the subject 1, so all these come from subnum 1. All right, that's all I guess we want to do for today. We'll maybe get into more reading when you guys start bringing in your own data to play with. But these will generally be sort of your go-tos. The reader package with its various read underscore something functions. And then if you've got lots of data to read, mapdf is the way to do it quickly. All right, well, yeah, we'll start talking about stats on Thursday. Wait, Thursday? Thursday, yeah.
And when we register a class